welcome back, welcome back. We're up to question number 33 on our 2016 final exam. The limit represented by this integral this limit represents the integral. Okay, and now we've got to sort of sort things out. This looks like a first principles integration. So I notice that I've got 2 by n off on the side with no i's in it. That's a great candidate for delta x. Okay, and delta x is b minus a over n, so I know that b and a differ by 2. So automatically I know that b is out, but it could be a, c, d, or maybe even e. But if that's delta x, then these 2i n's are going to turn into my xi's. Okay, and so if that's my xi, well, xi is a plus I delta x. So a's got to be 0, and so b will have to be 2. Well, no surprise, a, c, and d already have 0 and 2 there. But this turns into my function. This is f of xi. So if I change all the xi's to x's, I get x minus 1 times x plus 1. That's f of x. That's the thing I'm integrating. Okay, and well, that's not the function I see in D or C. It is the function I see in A as long as I'm willing to remember difference of squares. So it turns out A is the answer. Fantastic. All right, 34. So we're integrating from 0 to 4, square root of 16 minus x squared plus 1. Now the plus 1 I can deal with pretty quickly. Turn it into its own separate integral. And antiderivative of x would be 1. So 0 to 4, and we'll get 4 minus 0. So whatever we're doing, we're going to add 4 onto it. But what is this? What is this sort of shape? And we might remember these square roots of squares minus x squared. This is actually going to be a quarter circle, going from 0 to 4. And I can see by 16 is 4 squared. We're going to have a radius of 4 here. So this part here is a quarter circle of radius 4. So 1/4 pi r squared. R is my radius. 4 is my radius. So we'll get 16 by 4. So that's 4 pi. And we add 4. So 4 pi plus 4. That's an answer of D. All right. So that's the halfway point for this video. 35 here. Suppose we've got this relationship, and we might remember that this means f of x is odd. Okay? We're odd if the minus signs come out. We're even if the minus sign doesn't change anything. Alright, and we know that 0 to 2, f of x is equal to 3. Evaluate, well, we're evaluating over a symmetric interval. I'm going to bring the 4 out. You don't have to, but I think it's a little more obvious when we do this. F of x is going to be an odd function, as we said. What happens when you integrate an odd function over a symmetric interval? You get 0. Okay, nothing we need to worry about there. The answer is A. 4 times f of x is also odd. 4 is an even function, and an even times an odd is odd. But I think it's easier just to bring out the 4 and say, look, I'm integrating over a symmetric interval with something that is quite clearly odd. Alright, so the last question for this video, 36. And what have we got for question 36? So we want to integrate from 0 to 4... absolute value of root x minus 1. Now, absolute value is we're gonna look like 2 different things. Okay, sometimes we'll look like one function. If root x is bigger than 1, root x minus 1 will be a positive thing. And we'll flip it the other way, so we'll do minus root x minus 1, which of course, if you bring the minus sign inside, will just turn into 1 minus root x. If subtracting 1 away from root x would make it negative, so that's if root x is less than 1. Well, when does that happen? I mean, is 1 always bigger than the other between 0 and 4? I'm not sure. So here's where I would maybe draw a little sketch. So going from 0 up to 4, root x sort of looks like a parabola on its side, and 1 just sort of comes straight across. And these guys do intersect. They intersect if you square both sides when x is equal to 1. And I can see from my little picture, between 0 and 1, 1 is going to be bigger than root x, so we'll be down here, and our absolute value will look like 1 minus root x. after 1, but before 4, we're going to look like root x minus 1. Nothing will have changed because root x is the bigger function. Okay, so get a little more space here. So we can break our integral up into 0 to 1, 1 minus root x dx, and then 1 to 4, root x minus 1 dx. Okay, so we'll have x minus 2/3 x to the 3 over 2, 0 to 1, and then 2/3 x to the 3 over 2 minus x, 1 to 4. Okay, so that'll be 1 minus 2/3 minus 0. The zeros won't do anything. Plus 4 cubed is 64, square rooted is 8, so that'll be 16. 2 times 8 is 16 over 3 minus 4. And minus, plug in 1 in there, so 2/3 minus 1. So that'll be 1/3 plus 4 is 12/3, so 4/3 plus 1/3. That'll be 6/3, and that'll be 2, and there we go. Okay. I know I've gone a little into 37, but of course I'll wipe the slate clean before that video. So join me for 37, 38, 39, and 40 in the next video.